Hi everybody, today we are talking about prime factorization. Kind of sounds like a transformer or something, so we should have a little picture of factorization. If somebody can come up with a logo, that'd be really fun. We will also be implementing a holiday tree in our room, and it will be the factor tree. So as soon as that comes in, I will have all of you help me decorate ornaments, and we'll figure that out to get the prime factorization of a very, very large number. We're going to start small here, and we're going to start by finding factors. And I'm going to teach you the rainbow method. So if we are looking at the number 12, and we want to see all of the factors of 12, the first thing that we're going to do is we're going to start with the 1, because you always have 1 in 12. Those are easy to miss because they're so obvious. And then I know that 2 goes into 12 because it's an even number. So on this side, I'm going to put a 2, and this would be a 6. I'm going to put commas in the middle so that doesn't look like a 12. And so I am going to do this. I'm going to draw a red bow right here. I'm going to draw an orange bow right here. And then I know that I can do 3, and I can also do a 4. And I get that yellow bow. Now, if I go beyond that, I know I have 4 and 3, but now I'm starting to repeat the same factors. So if you have all of the pieces of your rainbow, you are going to have all of your factors. So now let's look at another number. Let's look at the number 14. So again, we know that we have 1 and 14. And we can draw our rainbow red. And then it's even, so I know that there is a 2 and a 7. I'll draw my orange. And you know, I'm looking at the number 3, 4, 5, 6, and there's nothing in between here. So I know that that is all of the factors of 14. This is a nice technique because you have both sides. Sometimes you can go 1, 2, and then 14 and forget the 7, or especially when you're doing a 12 or a 24, it's easy to leave one of those out. So I'm going to show you a question where we would use this information or this data. So if we look in your book, a dance teacher is planning a dance for a show. The dancers will be in rows with the same number of dancers in each row. Does a group of 12 dancers or a group of 14 dancers offer more possibilities? So we could have, if we look down here, we could have a group, just 1 in each row, and 12, 2 in each row, and 2 rows of 6, 3 rows of 4, 4 rows of 3. But in this one, we could have 1 row of 14, 2 rows of 7, or 7 rows of 2. I definitely think that a group of 12 dancers offers way more possibilities. When we look at the idea of divisibility, there are a group of rules that I am going to pop up on your screen, and then I want you to copy these down. These are wonderful to have while you are doing your assignment because they make figuring out if a number is divisible by a certain other number makes it way, way easier. So I will pop that up here. All right. So take a minute and take a look at the rules here about what whole numbers are divisible by. Many of us already know 2, 5, and 10, but did you know, obviously, if it's divisible by 2 if it's even, but 3. So if you add up the sum of the digits, and that sum is divisible by 3, the whole number is. So if you look at the number 12, 2 plus 1 is 3. 3 is divisible by 3, obviously. 3 divided by 3 is 1. What about 24? We know that's divisible by 3 because 8 times 3 is 24. But if you add a 2 plus a 4, that's 6. 6 is divisible by 3. It's divisible by 5, obviously, if it ends with a 5 or a 0. Many of us knew how to do 5, 10, 15, 20, 25, 30, and we thought that was so cool when we were younger. But did you know in the number 6, it's divisible by 6 if the number is both even and also divisible by 3. So again, you need to add up the sum of those digits, and if it's an even number to start with, that's one check. And the second check that you need is when you add those digits up, is it also divisible by 3? It's divisible by the number 9 if the sum of its digits are divisible by 9. So think about the sums that we have in the factors or the multiples of 9. So if we have 18, 8 plus 1 is 9. Some of you already knew how to do this because you already knew to add the digits up when you were learning your 9's facts. You knew that the sum of the digits actually added to a 9. 4 plus 5, 45. 4 times 5, or 5 times 9 is 45, excuse me, and 4 plus 5 is 9. Let's do 9 times 7 is 63. 6 plus 3 is 9. So you can see that rule, it isn't quite as obvious, but it's really handy to know. It's easy to tell the tens because tens, if it ends with a 0, it is divisible by 10. Let's do a practice with one of the numbers, and let's choose a really big number. Let's do 1,584. Okay, so right now, I am going to just add up the sum of the digits. So I'm going to start with 8 plus 4 is 12. And you can do this in any order that you want. So 12 plus 5 is 17. Plus 1 is 18. So I like to put a little number down there just to know that that's the sum of the digits. Some people like to do a little plus 18 to remind them that it's a sum. All right, so if we go through the list, I know that it's divisible by 2 because it's even. Is it divisible by 3? Well, is 18 divisible by 3? 6 times 3 is 18. So I do know, yes, it's divisible by 3. Is it divisible by 5? Does it end with a 5 or a 0? Nope, it does not. What about a 6? Is this number even? Yes, it is even. And it also asked me if it's divisible by 3. Well, we've already established that, so yes. All right, is it divisible by 9? Is the sum of the digits divisible by 9? Well, the sum of the digits is 18. So yes, it is divisible by a 9. What about 10? Nope, it does not end with a 0, therefore it is not divisible by 10. This is a good piece to have out when you're doing these questions on your assignment and on your test. I would try to commit them to memory, especially this one, the 6, 3, 6, and 9. They're not as well known, but they're very, very handy to know. The next concept that we are going to work with is the idea of prime and composite numbers. A prime number only has 2 factors, and they have to be greater than 1 and only have factors of 1 and itself. Okay, it has to be, and I'm going to make sure you remember that that is greater than. So a composite number is also greater than 1. That's a specification. We'll talk about that in just a moment. And it has factors other than 1 and itself. So the special numbers in this case, a lot of kids ask about, what about the number 0? 0 is a special case number. It is neither prime nor composite. 0 times 0 is 0. There are no other factors of 0. Also, the number 1. There's only one factor of 1, and that's 1. So these two are special cases, and they're neither prime or composite. So just remember that as you go along. Sometimes you'll think, oh no, I think maybe 1 is prime. No, it's not. 2, however, is prime. It's your only even number that is prime because you have two factors, 1 and itself, which is 2. So let's look at a couple of numbers. Let's look at the number, one that a lot of students will miss is try number 49. Is that prime or is that composite? You can pause the video and make a guess. Okay, this one, it looks like, you know, it's an odd number, it's a goofy number, it's almost 50, so you think, no, that's got to be prime. It is composite. Remember, if you did the rainbow method, you would have a 1 and a 49. And then if you remember, what about 7? 7 times 7 is 49. Now, just because it does have this extra fact, I know it's 7 to the second power, we can't write that 7 twice. It's 7 times 7, so its factors are 1, 7, and 49, but it has more factors than 1 in itself. Barely, but it does skate by, so it is composite. Let's do a few up from that. Let's do 51. Is 51 prime or composite? Pause the video and take a look at this number and do some of the divisibility rules and see what you think. All right, so we know that this number is not divisible by 2. But is it divisible by 3? 5 plus 1 is 6. 6 absolutely is divisible by 3. All right, is it divisible by 5? No. Is it divisible by 6? No, because it's not even. If it's even, it is divisible by 3, but it's odd, so that one doesn't work. Number 9, the sum of its digits is 6. It's not divisible by 9. And then we also have 10. So we need to see 3 times what is 51. So I'm going to take 51 over here and divide it by 3. And I am going to get, 3, sorry. 3 goes into 21, 7. Ah, I see why I didn't catch that one. It's 3 and 17. So it has the factors of 3 and 17 in addition to 1 and 51. So that one is also composite. Try the number 17. What do you think? If you said prime, that's it. It is a prime number. It is wise to always go through the divisibility rules. A lot of students miss numbers that look kind of wonky because they're odd. You've got to check those odd numbers to make sure that they are prime or composite.